Hello, I am back after a very, very long time with another tutorial. Okay, this one is about point rotation. Whoa, wow, so advanced. It's quite simple, but if you try to understand the math, don't do it. Save yourself the brain power. Just copy the equation I write down. It's that simple. Anyways, we're going to create two functions. One, to rotate the x-coordinate, and 2, to rotate the y-coordinate. You specify the x and y in both of them and the angle. I'm pretty sure you could probably mush the two functions together to create one function that rotates both of them, but I'm gonna just create two for now, so you can see what both of them do individually. First one is going to be 3 parameters, well, same as the other. It takes in the x-coordinate, the y-coordinate, and the angle you're trying to rotate by. And we're going to do degrees, but we're going to convert it to radians, because degrees is a smaller value, making it easier to rotate. What you want to do is x times the cosine of, and remember, we're doing degrees, so angle your degrees times pi over 180. If you switched the pi and the 180, that would convert it to radians, but no, we're not doing that. We're converting the degrees to radians, and the radians will be a very small value when we do this. Minus the y times sine of your angle, which is times pi over 180. Now for the second one. The parameters can be the same, but we need to change this because that way it knows both of them are different. For this one, we have to do x times the sine, and then the conversion, plus y times the cosine, and then convert it to radians. Now, we have the two equations that will convert the coordinates for us, for the x and for the y. And I will be using a slider value, like, say, b. We're just going to have it 0. Start at 0. It's going to do a step of 1, because this will show you, like, the rotation working, and it will not, like, the coordinates will perfectly follow the circle, like the circumference of the circle, and the radius of the radius for the rotation is depending on how far the original point is away from your center, which we're just going to have it right here. You would modify these two values here and then re-add it at the end. That way you can have it, rotate where you want it. But for now, we're just going to keep it like this. Okay. For point 1, we're going to do just 10 units to the right. Make it simple. And I'm going to make all of these not draggable to just make it easier to show you without anything accidentally getting messed up. Now, we're going to do point 2, and this is the point we're rotating based off point 1. We're going to do f of, and then for each function we have to do the x and y's of point 1, and then we're going to do b, which is the degrees, and then second function for the y-coordinate. It probably is more efficient to just have the function return the x and y, but like I said, I feel like it's better if you just see both of them separate rather than mashed together, so it's easier to read. And also, if I do r, I can't make it like go like that. I'd have to drag this, and well, I might accidentally go like this. See, And you just saw the rotation there. Because it would go way too fast, and I'd rather, if I click this, see? It's rotating perfectly. And, well, that's pretty much all you need to know. I'm going to change this here. There we go. And I'll create a third point, which will be at origin. And something I just discovered before I start recording this video. You can put the values of other labels, well, not labels, but other variables within these. Just do $, curly bracket, and then the thing you're trying to get the value of, then end curly brace. And I'm gonna do Windows emoji thing so I can get a custom degree. There we go. So I don't have to search it up. And that will tell you how many degrees it is. And, alright, forgot, don't want it to be rotatable. And now, if we play the slider, you'll see, and it tells you how many degrees it is. This is pretty fast, so it's probably hard to read, but, see? And so you can understand it more easily, I'll do 30. Oh, whoops. And I'll do a negative B because, yeah. Now if I do 120, see? 120 degrees of rotation. If I do 270, okay, 220, see? That's 220 degrees of rotation. And of course, if I go past 360, it still shows it here because it's doing this value, but, I'm actually gonna, so if I do 200, yeah, so the 560 passed the 360 degree, so when I did 560 there, it went fully, and then the difference between 560 and 360 is 200, so it went 200 degrees extra. Now, if I did, say, 2000, let's just minus 360, yeah, okay, 1640 minus 360, okay, okay, so okay, so, yeah, if you keep adding zeros, it's just going to, oh, never mind, it starts changing at some point, but, seems like around 15 zeros, it seems like it just, that's like the boundary point for it, because it's not changing. Ah, crap, I just deleted it. But yeah. Okay, well, okay. Well, hopefully this helped you understand point rotation, and hopefully it made it easier to understand. Yeah. Remember, if you want to get, you know, if you want to be able to rotate by small amounts, you have to do your degrees times this right here, pi over 180, because that will give you it in radians. And if you want to do like degrees, you have to do a very, very small amount of radians, because radian is like, because radian, you should probably watch a video to understand radians, but based on what I know, a radian is like 57 and some change of degrees. That's how many degrees it is. Like 57 and a little, and just a tiny bit more. Here, I'll show you. Ignore that. As you can see, oh wait, whoops. I did the wrong conversion. See? That's how many degrees are in 1 radian. Ignore the Among Us background you just saw. But yeah. Wow, I suck at these tutorials. Well, bye. Hope you enjoyed the video.